All right, class.
Yes.
Oh, thank you. I waited till you took a bite just so you could actually have to try to say it with a full mouth. It's even funnier. Anyway, uh, yeah. Anyway, we had a good practice yesterday. You missed out.
Oh yeah, I was in gamer skills.
I had like 16 people in there with all the computers working.
Oh, then you didn't need me. That was fine.
We didn't need you, but it was a good practice. It's not a need. Okay. Anyway, all right, for all those people that are following along, paying attention, thank you very much. I greatly appreciate you, and not implying that anyone in here is not here when they're supposed to be here. So, here you go. What? Yeah. Is she even at the school anymore? I haven't seen her at all because she owes me a calculator. Yeah. Anyway. Guess not. No, because we're just talking about meow meow. And then we're like, oh, I'm like, is she even here anymore? I haven't seen her even at school. And then the door opens. So we're like, no. Now implying that we're not happy to see you. We're doing 3.4. Derivatives, logarithm functions. Okay, so these ones are going to be easier than the inverse trigs that we had before. Because inverses switch the x and y, then try to change it up and do some derivatives. So, yeah, this is less crazy. This is a bit straightforward. So, following statements are true. Okay, we have this and this. Okay, these are inverse functions of each other. Okay, that's it. Exponential, and this is logarithm. So the opposite of exponential is a logarithm. So I could rewrite one as the other as inverses. They're not canceling like multiply and divide will cancel each other out. These are inverses of each other. So derivative logarithm function we have, so we are taking the derivative of y equals log base a of x, where x has to be greater than 0. Has to be greater than 0. Because it doesn't work out the other way. You can't have, numbers like 0, base 0, or base negative number on there. That don't work. So, you get this formula, so we can say, hey, okay, we get the derivative of this is going to give me this right here. Just like you don't have to go through and do the formula and try to figure out the formula yourself, you just do this right here. So whenever you see log base a of x, we get my derivative is 1 over x ln a. That's important. And then for the natural log, it's going to be the derivative is going to be ln x is going to be 1 over x. So the derivative of ln x is just 1 over x. Okay, important. Look at this one. All right, so we kind of got a chain rule here, right? Say yes.
Yeah.
We kind of got a chain rule for this first one. So what's my u going to be? Yep, ln x. So u equals ln x. So u prime is going to be 1 over x. Very good. So over here, I'm going to have u squared. So my derivative of u squared is 2u times 1 over x. And then do what? Plug it in. So I'm gonna plug in. Yep, ln x. So it's 2 over x, because I'm gonna put those together right there. And u is, so it's gonna be times ln of x. Next one. Do I have another? Yeah, so it's 1/2 log x. Now this is important. This is where you have to go back to that pre-calculus stuff, or even that algebra 3-4 stuff. What's the base if it just says log? Perfect, good job. So the base is going to be 10. So if you only see the word log, you zoning out?
Yeah.
Okay, okay. So if you just see log, it's implied that there is a base 10. It's implied that there's a base 10. So by knowing that, I know my derivative. So it's 1/2, so it's going to be 1/2 times the derivative of that. And let's go back to it. So what is the derivative of log base a of x? 1 over x ln. What's my a value going to be?
10.
There we go. So it's 1 over x ln 10. There we go. And we could put it together. So it would just be 1 over 2x ln of 10. Is that crazy? Maybe a little bit. Not too bad, right? Okay. All right, so let's go back and look at what C was. C said, C se puede, ln x ln y equals 2x. Now, what type of problem is this one here going to be? It's a certain type of problem if you, just because you notice you see the ln x and the ln y in the same thing. Anyone recall that word? No? Yes, there it is. Good job. Implicit. So it's going to be implicit differentiation. So that means we're going to take the derivative in terms of x. So we're going to take the derivative even of ln y, right? So we're going to do it all together at the same time. And then we're going to get ln, oh, I'm sorry, my implicit, which is dy dx, by itself. So the derivative of ln x is going to give me, what's the derivative of ln x? 1 over x plus the derivative of ln y is going to give me 1 over y, almost, dy dx. There you go. Remember, if we're taking the derivative of something that is not the x or not the variable that I'm taking the derivative of everything else, then we have to imply that what we're doing here. So we're taking the derivative of y in terms of x equals the derivative of 2x. You say 12?
2.
2, okay. Now what do I do from here? Subtract 1 over x, right? I'm trying to get the
dy over.
yeah, dy dx by itself. So subtract 1 over x. So now I have 1 over y dy dx is equal to 2 minus 1 over x. How do I get rid of that 1 over y?
You multiply by y.
Very good. Multiply both sides by y, and that's going to cancel that out on the left-hand side. So by multiplying by y to both sides, I'm now going to have dy dx is equal to, I'm going to bring the y out front because why not? Y times quantity of 2 minus 1 over x. Not too bad, right?
No.
Just refresher about the implicit. All right, let's go. I'm gonna back. Are you guys done writing it down? Okay. Still right. Denny, you got it? Okay. All right, I'm gonna back up a little bit. This is 3-4. I handed this out the other day. You weren't here? No. Okay, so. Ah! My mouse. Can't do that. 3. Uh, 3-4 and 3-5. All right, so we did see, and my last one now is log base 2 of x cubed. Log base 2 of, like that. So I myself like rewriting and putting in parentheses, especially for my logs or my ln's and stuff like that. Put what's that going to be in parentheses, because x cubed here is completely different than if it was here. And you're going to see both of those. You're going to see both of those. But right now, that's why I'm just putting it right here, so we know that the whole thing's not cubed. All right, is this one a u? Yeah, this is a chain rule, right? What's my u going to be? X cubed. So we're going to say u equals x cubed. So u prime is 3x squared. Very good. So that means if I rewrite this, this is log base 2 of u So what's the derivative of log base 2 of u going to be? Denny? What's the derivative of this going to be? Not x. U, ln 2. Very good. Times 3x squared over my u prime. Yep, so 3x squared. Good job. And all I have to do now is plug my u back in, right? Plug the u back in. So I'm going to have 3x squared. So multiplying this right here times the 1 out front over x cubed ln of 2. But wait, there's more. That x cubed and that x squared, what can I do with those? Simplify or cancel out 2 of them, right?
Cancel out.
So simplify, cancel, the same thing. I'm going to cancel out 2 of them. So I'm left with 3 over x ln 2. You guys feel pretty good about that one? Pretty solid, right? Okay, that took care of all those. All right. So, didn't we just do a bunch of chain rules right there? Yeah. This is the official designation of what the chain rule is for this. Even though we did it with actually doing the math, this is what it is going to look like in the Leibniz notation. So the u prime x over u of x. All right. And I want you people to try these three right now before I do it. And I'm going to put a dot here to show you that this is going to be a product rule on top of a chain rule. The chain rule first, and then a product rule. All right, so try this out, please.
Number 47.
47. For yesterday?
Yeah, you told me to.
Oh yeah, we'll do it.
Okay.
Yeah, we'll do it, and I'm actually done after these notes, and then so we can work on homework. Yeah, listen for you. This is you, so that's going to be very good. Why over you? Good one. Serious issue. What's the derivative of this, right?
I don't know. That's bad.
1 over this right here, right?
Yeah.
Somehow you screwed up when you subbed it back. Put it in the wrong place.
Okay.
It's 1 over u here, right?
Yeah, so it'll be 1/5x.
Change that. Sit. And what are you left with? So you're going to replace this with u. Like I did on the previous problem right here, right? That all this was my right? Right, u equals 5x. Okay, so you say u prime equals, very good. All right, write this with u instead. So very good. Okay, what's the derivative of ln x? This time we have ln, right? So the derivative is yeah. Next one's a little bit more complicated because there's a product and a chain. Right here was your u. Okay. Fine, cool. That's why I put a dot right there. All right, let's go through, and everyone should be at least done with the first one. So I'm going to say that this, so u equals 5x, u prime is 5, and then it's going to be ln u. So my derivative of that is 1 over u times u prime, which is 5, which is going to give me 5 over, subbing back, 5x, 1 over x. Okay? The next one is going to be a product. Here it is. Okay. So it was x times ln of x squared plus 1. All right, so we have a couple different things. So we have a product rule here and a chain rule here. So I'm going to say that u equals x squared plus 1. U prime is 2x. Now let's go through and do the chain rule. Okay, I'm not chain rule, I'm sorry, product rule. So my product rule means I'm multiplying. So I have two things here. Two things being multiplied together. So it's going to be f and g. So f prime, what's the derivative of this? So this right here is my f, and this one over here is my g. So the derivative of f is going to give me 1. G prime, so the derivative of that So now let's take the derivative of g. If I'm looking at g, isn't that just going to be 1 over u, right? Okay, so my derivative of this, because I u sub this one, so it's 1 over u, I said u, times u prime, which is 2x. So if I write this again, I'm going to put it all back together. So it's 2x over x squared plus 1. And that is my g prime. Not, hopefully. Yes? Are we okay so far on my product? And now let's put the product together, because my product is f prime g plus g prime f. So that's 1 times g, which is going to be ln of x squared plus 1, plus g prime, which is 2x over x squared plus 1, times f, which is just going to be x. Or I could just put it as x over 1 if that makes the math a little bit easier to see. So over here, I get just my ln of x squared plus 1 plus, and over here, I could multiply the tops, so that's 2 x squared over x squared plus 1. Alrighty, we good on this one? Let you guys finish. And if you look at the next slide, you'll realize kind of cheated on that one. Yeah, look at the next slide. Bruh. I know it's the same things, but it already gives it to you. All right, so for C, it says y equals ln absolute value of x. And so again, like I said, if you cheat and look at the next slide, it is going to be 1 over x. So it's the same thing. So nothing too crazy. We just get 1 over x. I know, but the derivative of this is just 1 over x.
Yeah.
Is the absolute value still there?
It's not.
There you go.
Okay.
Yeah, the absolute value is not there no more. And like I said, I was going to leave off right there. And so these, all this craziness, we're going to pick up again tomorrow. So make sure you all, actually no, Tuesday. Make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.